Hello. Today I'm going to talk about ideal controller, what concepts behind it, and how we can build it from scratch with open source tools, and what's requirements for our controller. At first, it should be flexible. We shouldn't limit to our tools, and at various layers, our stack should be interchangeable. And if we have performance bottlenecks somewhere, we should be in capability to easily scale our pieces of controller. And of course, we should rely on data models and not facilitate CLI to have better predictability in our networks. So what's the use cases? At first, controller will help us to better program our network, and users and network engineers can add some pieces, can enhance the controller logic at any level, and controller capability should be focused for any network, any size of network, and any scale. Let's take a look at idea for Egress controller, and we have multiple concepts here. I will deep dive into each of these concepts behind. And let's start from the bottom layer. We stream a lot of data from our network, from the routers itself, and we will utilize open config models to support vendor neutral devices, and we could fully rely on gRPC, for example, because later when we will trigger action, we can utilize gRPC for communication as well. So once data is streamed, we are going one level up, and we need some kind of collector to get all our data normalized and to add timestamps or to provide proper format for consumption stack. And once our data is normalized via collector, by the way, we may have multiple collectors. They could be like load balanced, or we can swap them, and we can stream from our devices to multiple destinations without additional like high load on CPU. So we have our data normalized. What's next? We should store this data somewhere. As an example here in controller, and I will be showing code for it, we will spin up Kafka, and Kafka will be used to store all our data. The beauty of it, it's very reliable. It's extremely easy to scale, and if you want to do Kafka cluster, you can just can have multiple servers where you want to deploy your, or if you want to start with very simple and not sophisticated setup, you can spin up a Docker container with one command, and all required applications would be running inside. So after the Kafka is running, our main communication and storage mechanism, we will need some kind of processor for our data. Because Kafka allows us to use multiple topics and multiple subscribers and consumers model, we will adjust our processor to specify only information we are interested in. It could be change, depends on the use case which we utilize. And once telemetry processor is subscribed to our Kafka bus, we are going to the next item is event. We start to monitor data which coming to our application, to controller logic itself. And in this event, it's going, I don't know, new route announced, or you have some problem with ports, or you want to monitor some prefixes and notice anomaly behavior. You can identify this type of events, and also you can specify intent. What are you going to do with such events? These pieces, it's good to decouple them. because you will be not limited to address new intents or to provide new actions on your network. And once our logic exceeded some threshold, for example, packet loss become too huge for you to handle, and you may to reroute your traffic, you trigger some action on your device to close the loop. And we are covering full cycle here. Once you start to receive your data from telemetry perspective, when you are processing this data, some specific topics, and if your internal rules are like broken, or some of the values exceeds the normal default value, you can trigger an action on your device. And there are multiple ways how to talk to the device to close this final loop, and we will talk about them as well. Previous session was a good coverage of telemetry, and streaming telemetry is a new approach. It's model-driven. We will fully rely on models. And in this controller, we will just leverage some of the open config models which are available on device. And the beauty of streaming telemetry, you may add new as many destination receivers as you want, because you may have some redundancy in your collector if one collector is broken, or I don't know, your hard drive is overfilled with logs and log rotate wasn't configured properly. You can have some redundancy in controller to not slow your network. And we have variety of models available from open config standardization. And we'll just, in demo, we'll get interfaces and local routing table to figure out what's going within our network. We need to specify some configuration on a device, and typical configuration would be the first destination group. It's for your network controller destination and port. Also, what's important is encoding, and we'll utilize JSON format because it's very straightforward to work with JSON in Python. And we'll use TCP for communication, but as I mentioned, gRPC could be utilized, or UDP. Once we specify a controller, we will need also to provide which exactly sensor paths we are going to utilize, and we will rely on open config paths. And once you are settled with your telemetry data streamed, you need to provide how frequently you want to stream this data. And once you configure all this information, you are ready to go. Let's move to our next component. And as I mentioned previously, we need to store our data somewhere. Kafka will be utilized to save our telemetry. And we will just use one topic for now. It will be called telemetry. But multiple topics could be configured. You can specify based on device, based on type of data. And you may also monitor your server infrastructure, as many topics as you need. And the beauty of Kafka, it's very performant. It's horizontally scalable with adding new infrastructure to Kafka cluster, and not much overhead in usage, in Kafka usage. The typical architecture of Kafka looks like this. You have producers, which is our network. So we have reverted picture over here because we had a network at the bottom and now a network on the top, which is producers. Broker kind of interact interaction between producer and consumer. And consumer our Python application. It's very, to start with it, we will utilize Kafka consumer library for Python, and you can subscribe to your Kafka bus with 2 strings of code. And major component here is Zookeeper. You will need Zookeeper to coordinate all your configuration, to work properly with naming, and it's kind of necessary and essential component to run Kafka, because without Zookeeper, Kafka will not start. So think about it as a mechanism which supplements and keeps Kafka driving. In this slide, we are going to talk how to start your Kafka, and if you're comfortable with a Docker container, you can run it just with one command, and you need to provide hostname and IP port which would be exposed. And once you are done with starting your container, it will be running, and now you are going to Python, and very, very simple, you start your subscriptions to specific topics. And in this code example, we subscribed to Telemetry, and we provide only one server to subscribe, and we start to receiving messages in our application. Our application will be independent. Intent and business logic would be independent, because we may want to close the loop to interact with devices on a separate instance. And I will show you in a demo. When it will be a separate instance, we are not limited to updates. If you want to introduce some new rules and you want to restart your application, your system is not monolithic, and you are able to update piece by piece and do some incremental changes on your network. And Flask could be used for that purpose, to just spin up a micro web server. You can identify endpoints for your application, and once endpoints identified, you can spin up some, you can run some actions against your routers, and do route injections or some configuration appliance, and it will be just like wrapper for glue for whole your system. And as I said, you can use Kafka consumer to subscribe and to get your data initially, or you can use traditional publisher subscriber like pattern, and it's also available in Python libraries through pip, and you can download and install and get started with it. And one last big piece is closing the loop, because we cover how we start to streaming telemetry. We didn't talk much about collectors, but here it may be based on the equipment which are you using. And now we are going to talk about closing the loop and how to talk to your device. There are multiple ways how you can leverage your network and programming utilities to communicate with boxes and apply new configuration, run some checks, or implement some rules or new configuration. The first is Netmiko and Napalm. First thing is Netmiko. It's just a wrapper on top of Paramiko. And the beauty of it, it handles all vendor neutral stuff for you, and you can apply configuration directly. And the Napalm is even going even higher on the abstraction layer, and you can apply actions directly. Netconf-Young is a well-known industry standard, and you can apply your your XML files or YAML models directly on the routers. And you will have more predictable conversation going on with your network. Configuration management tools such as Ansible, Pipet, Salt, choose your favorite, could be also leveraged. And here it's just a matter of your personal preference, or depends if the network device supports this type of configuration tool. Some simple approach could be used as well. For example, you may send just a static routes. You can send just a static routes to your device. And this is a good approach if you want to start with something simple, but you may need something better. And for some network devices, there is a RIP API, which allows you to do performance route injections, or RIP API, you can call it like that. And we will talk about it. So typical network device programmability, as I said, you can interact with on the higher level of your device stack through the management. It could be netconf, YAML, or some applications which will program the router directly, or you can go lower in the stack and go and program your device through service adaptation layer. Let's take a look how service adaptation layer works and what we need to do to start programming routes on our device. Here it's a little bit more sophisticated piece to start, because you need to know or to use once at least gRPC stubs, which we will need to create. And we will start by creating just route list, and we will fill the VRF parameters for our route list. And after this pre-initial setup is done, we will start to generate prefixes. Also, you can program any admin distance from 0 value up to whatever you decide. Once you create prefixes, you need to provide next hop, IP address, and interface. And once this piece of code is done, you need to append your existed path, because you can have multiple paths for, I don't know, 10, 20, thousands of the network with prefixes defined. And the beauty of it, you can do bulk updates as well. So you are not limited only to one route update, you can do in bulk. You can also utilize performance and increase performance and check if you want to do it in a batch update. Our previous routes going to just adding, or some of them were deleting, and you need to like post your batch because next route will be different type of announcement. So when your path is populated, you need to create another stub, and here we will just create two paths, and once all these actions are done, you just create a route list, add all your routes to it, and you initiate RPC call, and your routes are programmed and injected on your device. This is performant approach. You also stay in the same ecosystem, in the Python ecosystem, and you don't need any additional libraries or knowledge of any other languages programming. And here's just gRPC package needed for you, and you are good to go. And this is scalable approach, and our design is decoupled, and you can increase horizontally scale each piece of it, and start introducing your rules as you grow. And I want to show a small demo. You can check code components, how to do it and how to start. It's public. And I wanted just to summarize this with few worlds. But better monitoring of your network leads you to more predictable environment, which you have. Our components of controller are independent from each other, and you can start very simple, or when you are growing, you can introduce new sophisticated logic. And this is all in Python ecosystem, which easily deployable and good to start with. And fully open source, you can build it from scratch on your laptop and give it a try. Thank you for listening.